Have you ever looked up at the night sky and wondered what lies at the very edge of it all? Not the edge of the sky, not the edge of our galaxy, the edge of the entire universe. Is there a wall out there somewhere? A final door with a little sign that says the end? Or does it simply go on and on forever? It is one of the oldest questions our species has ever asked, and for most of history, we had no way to even approach it. But over the last 100 years, astronomers have quietly assembled an answer, and it is far stranger and far more beautiful than any wall could ever be. To find the edge, though, we first have to understand something deeply weird about the universe we live in. So tonight, we are going on a journey. We'll start close to home, and we will travel outward, step by step, as far as it is physically possible to go. And then, we will try to peek a little further. Our universe was born about 13.8 billion years ago, in the event we call the Big Bang. Now, light is the fastest thing there is. Nothing can outrun it. So you might reasonably assume that the farthest we could ever see is 13.8 billion light years away. The distance light could have crossed since the very beginning of time. Reasonable. Also completely wrong. The most distant galaxies we can see are currently about 46.5 billion light years away, more than 3 times farther than that simple answer. Which raises a rather awkward question. How can we possibly see something that is farther away than light has even had time to travel? The first clue arrived in the 1920s with an astronomer named Edwin Hubble. He noticed that almost every distant galaxy is racing away from us. And the farther away a galaxy is, the faster it is fleeing. At first glance, that makes it sound like we are standing at the center of the universe and everyone is running from us. Which, frankly, is a little insulting. But we are not the center. Nobody is. The real explanation is that space itself is stretching. Picture a loaf of raisin bread rising in the oven. Every raisin drifts away from every other raisin, not because the raisins are moving, but because the dough between them is growing. The galaxies are the raisins. Space is the dough. So when that ancient light was traveling toward us for billions of years, the space it was crossing kept expanding underneath it, carrying its starting point ever farther away. It is a little like walking toward a friend across a rug, while someone keeps pulling the rug the other way. You are making good progress. The rug is simply not on your side. And this is the key idea, so let's be clear about it. The galaxies are not flying through space away from us. The space between the galaxies is growing. Every point is drifting from every other point, with no center to any of it. From any galaxy in the cosmos, it looks like everything else is rushing away, including, from their point of view, us. This bubble of everything we can possibly see has a name. It is called the observable universe, and it does have an edge, though not a physical wall. We call it the cosmic horizon. It is simply the distance beyond which light has not yet had enough time to reach us in the whole history of the universe. Now here is the beautiful part. Because light takes time to travel, looking far away is exactly the same as looking back in time. When you see a galaxy a billion light years away, you are seeing it as it was a billion years ago. Look far enough, and you are not just seeing distant space. You are seeing the young universe itself, glowing in the past. So what happens if we look as far as it is physically possible to look? We run straight into a wall of light. For its first few 100,000 years, the universe was so hot and dense that it was opaque, a glowing fog through which light could not travel in a straight line. Then, about 380,000 years after the Big Bang, it finally cooled enough for that fog to clear. In that instant, light broke free and began streaming across space. And it is still arriving today, stretched by all that expansion into faint microwaves, reaching us from every direction at once. We call it the cosmic microwave background. It is the oldest light in existence. A baby photo of the entire universe, taken when it was just a few 100,000 years old. And we did not even go looking for this ancient light. We tripped over it. In 1965, two engineers were testing a giant radio antenna, and they kept picking up a faint hiss they simply could not get rid of. They checked their equipment. They evicted a pair of pigeons nesting inside. They scrubbed out the droppings. The hiss remained, coming from every direction in the sky. That stubborn hiss turned out to be the cosmic microwave background, the echo of the Big Bang itself. The two engineers went on to win the Nobel Prize for a signal they had first assumed was caused by bird mess on their antenna. It remains, I think, the greatest discovery ever nearly thrown out with the cleaning. And here is my favorite part. This ancient light is not some abstract thing locked away in observatories. It is all around you, right now. In fact, on an old television tuned to a dead channel, a tiny fraction of that fuzzy static was the cosmic microwave background itself. You were watching the afterglow of the Big Bang and complaining about the reception. This wall of light forms the practical edge of everything we can ever see. Beyond it lies the first few 100,000 years, hidden behind a fog no telescope can pierce. So the wall at the very edge of the observable universe, it turns out, is not made of brick or fire or anything solid at all. It is made of the universe's own first light. But wait, the cosmic horizon is the edge of what we can see. That is not at all the same thing as the edge of what exists. The universe almost certainly continues far beyond it. So here is the real question, the big one. Is the whole universe finite, with a true edge somewhere far out of sight? Or is it infinite, going on forever? The honest answer is that we do not know for certain. But we do have a powerful clue, the shape of space itself. Space can, in principle, be curved. It might curve back on itself like the surface of a sphere, finite, but with no edge, the way you can circle the Earth forever without ever falling off. Or it could curve outward like a saddle, or be perfectly flat. And we can actually test which one it is. On a flat surface, the three angles of a triangle always add up to 180 degrees. But on a curved surface, they don't. So astronomers measured a truly enormous triangle across the sky, using features in that ancient background light as their ruler. It is geometry on the largest scale imaginable. And the verdict is in. As far as we can measure, the universe is flat, astonishingly flat, flat to within a fraction of a percent, which is honestly a little anticlimactic, like sailing all the way to the edge of the map and finding that someone has carefully laminated it. But that flatness carries a truly staggering implication. It is also a genuine puzzle. For space to look this flat today, the early universe had to be balanced almost impossibly perfectly, right on the knife's edge between curving inward and curving outward. Tip it a hair one way, and it collapses. A hair the other way, and it flies apart before stars can form. Why it was tuned so precisely is a question we are still chewing on. And if space really is flat and does not curve back on itself, then the universe may well be infinite. Not merely very, very large. Infinite, stretching on with no edge, no boundary, and no end. An endless ocean of galaxies, of which everything we have ever seen is a single, tiny drop. Though we should say clearly, this is the leading idea, not a settled fact. Now the story takes a darker turn, because space is not just expanding. Back in 1998, two teams of astronomers measured distant exploding stars, expecting to see the expansion gradually slowing down under gravity. Instead, they found the opposite. The expansion is speeding up. Something is pushing the universe apart, faster and faster. We do not know what it is, so we gave it a suitably mysterious name, dark energy. It appears to make up about 70% of everything, and we can barely describe it beyond that. It is the largest thing in the universe, and also one of the largest holes in our understanding. And this accelerating expansion changes the edge in a rather frightening way. Because everything is being pushed apart ever faster, there is a distance beyond which galaxies are being swept away from us faster than their own light can ever swim back. This boundary is called the cosmic event horizon. Any galaxy that crosses it is gone, forever unreachable, even in principle, even at the speed of light. And there is a darker possibility still. If dark energy grows stronger over time, the acceleration could one day become so violent that it tears apart galaxies, then solar systems, then planets, and finally atoms themselves. Physicists call this the Big Rip. It is, mercifully, not the favored scenario right now. But the universe has surprised us before, and it does not consult us first. And that horizon is very slowly closing in. One by one, over almost unimaginable stretches of time, the distant galaxies will stretch, redden, dim, and finally slip past the edge into permanent darkness. The universe, it seems, is very politely showing all the other galaxies to the door, and it is not the kind of party you get invited back to. In the far future, a civilization on some distant world will look up and see only their own galaxy, alone in a completely empty black sky. Every other galaxy will have vanished beyond the horizon long ago. They will have no way of even knowing the cosmos was once full of light, which means, strangely, that we are lucky to be alive right now, while we can still see it all. Alright, let's finally ask the forbidden question, the one every cosmologist gets asked at parties and quietly dreads. If the observable universe is a bubble, then what is outside the bubble? What actually lies beyond the edge? The honest and slightly boring answer is, almost certainly just more universe. The same kinds of galaxies, the same physics, simply too far away for their light to have reached us yet. Some estimates suggest the whole thing is at least hundreds of times larger than the part we can see, and quite possibly infinite. The edge is not where things stop existing. It is only where our information runs out. But some physicists go further. Our best theory of the Big Bang, called inflation, hints that the event which made our universe may not have been a one-time affair. It could still be happening elsewhere, endlessly, blowing up new regions of space into entirely separate universes, each with its own Big Bang. They call it eternal inflation. This is the idea of the multiverse, and in some versions, those other universes could run on completely different rules. Different particles, different forces, perhaps no stars or atoms at all. Universes where the dials of physics were simply set to other numbers. We want to be very clear here, though, this is speculation, not established science. We currently have no way to see another bubble. Perhaps we never will. And that is the strange place we find ourselves in. The edge of our universe might be the edge of absolutely everything, or it might be just one small shoreline on an infinite sea of other universes, each one glowing away, forever out of reach. For now, both pictures fit the evidence about equally well, which is a very polite, scientific way of saying we genuinely have no idea. There is one more edge we have not talked about yet. This whole time, we have been chasing the edge of space. But there is also an edge of time, an ending, not far out there, but up ahead of us, waiting. Right now, we live in what astronomers call the stelliferous era, the age of stars. The sky is full of them, forging light and warmth and the atoms that make up you and me. But this era, as grand as it is only a brief chapter. And the chapters that follow it get very dark and very long. If dark energy keeps on winning, then over trillions upon trillions of years, the stars will burn out one by one. No new ones will form. Galaxies will drift apart and grow cold. Eventually, even matter itself may decay, and the black holes that remain will slowly evaporate into nothing. The cosmos will settle into a thin, cold, featureless dark. For a long, strange age, black holes will be the last structures left standing, the final dark lighthouses of a dying cosmos. But even they do not last forever. Over spans of time so vast that the numbers genuinely stop meaning anything, black holes slowly leak their mass away and evaporate. And when the very last one quietly winks out, the universe will be truly, finally, empty. Physicists call this the heat death. It is not an explosion or a bang. It is the opposite. It is the universe running out of the one thing that makes anything interesting happen: differences in temperature. When everything, everywhere, is the same cold nothing, time itself stops having much meaning. That is the true, final edge of the universe in time. It sounds bleak, I know, but look at where that actually leaves us. We are living in the brief, brilliant morning of the universe. A narrow, precious window, when there are still stars and planets and warmth, and someone around who is curious enough to wonder about the edge at all. On the cosmic calendar, that is nothing short of a miracle. So, after all that, what is actually at the edge of the universe? Let's gather what we have found. First, there is a wall of ancient light, the cosmic horizon, that we can never see past. It is the edge of our vision, not the edge of reality. Beyond it, there is almost certainly far more universe, possibly infinite, an endless ocean of galaxies we will never reach. Possibly other universes entirely, running on other rules. And wrapped around all of it, a quiet horizon that is slowly closing in, and an ending in time, far up ahead. Not one single answer, but a whole stack of mysteries, each one somehow larger than the last. Alright, everyone, before we head off to the edge, it is time for a little quiz. Let's see if you have been paying attention. Here is tonight's question. We said the most distant galaxies are about 46.5 billion light-years away, even though the universe is only 13.8 billion years old. So what makes that possible? Is it A, the galaxies are moving through space faster than light? B, space itself expanded while the light was traveling? Or C, the light took a shortcut through a black hole? I'll give you a moment to think. The answer is B. Nothing can move through space faster than light. But space itself has no such speed limit. As it stretched, it carried those galaxies far beyond the simple distance we first guessed. Space, you might say, is the ultimate cheat code. So the edge of the universe is not a wall after all. It is the limit of how far light and time will ever let us see. And maybe that is the most human thing about it. We are small, temporary creatures on a wet little rock, orbiting an ordinary star. And yet we have somehow mapped the boundary of everything we can know and dared to peek, just a little, at what might lie beyond it. Whatever is out there, past the horizon, it is out there right now, glowing quietly, whether we can see it or not. Thank you for traveling all the way to the edge with me tonight. If you enjoyed the journey, do consider subscribing, because there is a whole universe left to explore. So, until next time, I will see you in another world.